Welcome to this fascinating relative velocity problem. We have a frictionless horizontal surface, which we'll treat as the xy plane. Watch as I set up our coordinate system with the x-axis pointing right and the y-axis pointing upward. Here's our green trolley labeled A, moving along a line parallel to the y-axis. It travels at a constant velocity of square root of 3 minus 1 meters per second, which is approximately 0.73 meters per second. At this particular instant, notice that the line from the origin O to the trolley makes exactly 45 degrees with the x-axis. At the origin, we have a red ball ready for launch. The ball's velocity will make an angle phi with the x-axis. Our task is to find the angle theta that the ball's velocity makes in the trolley's reference frame and then determine the ball's speed if phi equals 4/3 of theta. Now, here's the crucial physics insight. For the ball to hit the trolley, the ball's velocity relative to the trolley must point directly along the line joining them. Let me show you the relative velocity vector. The relative velocity equals the ball's velocity minus the trolley's velocity. Since the line OA makes 45 degrees with the x-axis, the relative velocity must also make 45 degrees. This means the x and y components of the relative velocity must be equal. So we get the equation v cosine phi equals v sine phi minus u. Now let's answer part A. In the trolley's reference frame, the ball appears to move with the relative velocity vector. The angle theta this makes with the x-axis has tangent equal to v rel y over v rel x. Since these components are equal, tangent theta equals 1, which means theta equals 45 degrees. For part B, we're given that phi equals 4/3 of theta. With theta at 45 degrees, phi becomes 60 degrees. Now we can find the ball's speed. Substituting phi equals 60 degrees into our collision equation, v times cosine 60 equals v times sine 60 minus u. Rearranging this equation, v over 2 minus v times square root of 3 over 2 equals negative u. Factoring out v times 1 minus square root of 3 all over 2 equals negative u. Solving for v and v equals 2, u divided by square root of 3 minus 1. Since u equals square root of 3 minus 1, the beautiful result is v equals 2 meters per second. Now watch the magic happen. I'll launch the ball at 2 meters per second at 60 degrees. See how it tracks toward the moving trolley. The relative velocity points exactly along the line of sight, guaranteeing the collision. And there it is, a perfect hit. Let's summarize our answers. Part A. In the trolley's reference frame, the ball's velocity makes an angle theta of 45 degrees with the x-axis. Part B. The ball's speed with respect to the ground is exactly 2 meters per second. The key insight was recognizing that for collision, the relative velocity must align with the line of sight.